Okay, very welcome to everybody who's listening and all the youngsters with the young minds. So here we are back again with the Net the Niche series with another amazing interview with somebody that I met recently, Dr. Moshe Klein. Now, what happens is, let me introduce you with a different thing altogether. So I have taken a few lines from his work, which started way back in 2000. That's a long time back from now. And what he says, listen very carefully. So in mathematics, Socrates said that I know that I don't know. But a couple of years, in number of centuries later, Hilbert said, I know what I don't know. But then we had another great philosopher, mathematician, and a thinker, Goedel, and he came and said that I can't be proven. Then again, Hilbert came into the realms and he said there is a sixth problem, which is an organic quality. Now, wait, we're going to ask the person who's written it to get into a little detail about it. But what he said is there's a sixth problem in an organic quality. The solution is the problem. Interesting, isn't it? And it contains inherently the formulation of the problem itself. And it goes into discuss the aspects of maths and real world and six different pointers. There's six different aspects altogether: subject, logic, reality, imagination, paradox, and object. Wow, that's an entire basketful. So I would like to welcome our beautiful guest today, a mathematician. His doctorate thesis was on the subject of soft logic. He's a researcher in the Consciousness and Soft Logic Lab. He's the founder and propounder of Gan Adam Project, which was established way back in 1990, and that was aiming at developing of mathematical and scientific thinking among preschoolers. How cool is that? And since then, they have worked in hundreds of kindergartens with students, with teachers throughout Israel. And of course, let me just quickly point out, he holds a master's degree in mathematics from Hebrew University and a master's degree in maths from Technion. Now, that's an amazing advantage that we have today with a mathematician here, and the one who is inspired by Ramanujan, our very own Indian soil mathematical genius. Now, I would like to welcome you, Dr. Moshe, and I am so super excited to have you here, and especially thank you to agree to be part of this interview. Now, this is going to be an eye-opener. I met him recently at an international conference where we both were presenting our research papers, and instantly I was so glued and inspired by his presentation on soft logic. So we'll dive into it later, but can I just say I'm so super excited that you took out the time today.
Hi, Monica. Thank you very much.
Thank you.
Thank you to be with you today. It
Fantastic.
was a great pleasure to meet you in India. A week ago, we met at the conference, very exciting conference about positive thinking, positive psychology, well-being.
And spirituality.
It was wonderfully organized at HIT and the Incubator Center with wonderful people. So, first of all, I want to say that I'm working together with my partner, Professor Oded Maimon. He's a researcher at Tel Aviv University, and we are leading today this project of soft logic. In the conference, there was also Avishai Galili, he's a philosopher, is working with us. So this is on the background of everything. And we are looking forward to share this knowledge in India, especially with the wonderful Indian culture, and looking for projects and collaboration.
Fantastic.
So now I'm ready to the question. Yes.
Fantastic, Dr. Moshe. Now, I'm very interesting. You mentioned, and there is a quote that I wanted to pick up to start, that you say that is, I'm excited from the possibility of paradigm shift in mathematics. How amazing is that? That is a very fine and very deep thought process that you have. So can I ask you with the first question? Can we start with the first question?
Yes, please. Look, what
Fantastic.
is the
So first is I would like for our audience to understand the genesis of mathematics, of soft logic, of your discovery, the kind of work that you have done. But let's start where it started early on. As you shared the concept, the ideation started way back in 2000s. And that was where your research paper, your first research paper on organic maths was published, and you shared it. Now, it was basically the mathematical experiment to solve the sixth problem of Hilbert. Now, can you tell us something about the early journey of the discovery?
Okay. I have a great love to mathematics, from young children. I remember myself at the age of 6, at kindergarten, like to make adding of big numbers. So I'm one of the one who was crazy with numbers, with mathematics, and I study mathematics at the Hebrew University. I was a very good student, and I read the words of David Hilbert. David Hilbert was a great mathematician, the greatest mathematician in the 20th century. And in 1900, he gave a famous lecture in Paris in the International Conference of Mathematicians, when he posed open problem, a list of 23 unsolved problems in mathematics. Usually mathematicians present their achievement, what they did, what they succeed, what they proved. And it was amazing lecture that the greatest mathematician in the world give a lecture about 23 unsolved problems. And this was very exciting for the mathematician. They tried to solve his problem. Until today, still there are few unsolved problems. But Hilbert ended his lecture with something very interesting. He said, these are only example of problems. I could choose other problems to demonstrate. What important for me is to show you that the vitality of mathematics, that mathematics is a living organism. He was afraid that mathematics will split to many branches and that each mathematician won't know what the other mathematician is doing. He was afraid from that. So he ended his lecture with a vision, with excited vision, to discover the organic unity of mathematics. And when I was a student, it was in 1980, I read this vision and it enlightened me. So this was my passion until today, to discover the organic unity of mathematics. So I draw a picture of a face of mathematics, which was include many drawing from many branches of mathematics. This was my excitement, but I searched for many years this unity, this organic unity. And I decided not to go in the traditional way to do PhD, to be professor. No, I chose a different direction. I decided to go to kindergarten. We will talk about it later, why kindergarten, but I dedicate myself to work in environment of young children when they love mathematics, when they are excited. And I came to kindergarten not to teach them mathematics. I came to kindergarten to study from them, to study from the young mind about mathematics. And this was the direction. So in 2000, it was a turning point, really, that I organized a conference in Israel, 100 years to Hilbert, to this famous lecture. It was 100 years after the lecture of Hilbert. So it was very successful. It took place in the town Kiryat Shmona in the north. And then I heard that the American organizing a conference with the same title, 100 to Hilbert. It was take place in California, in Los Angeles, in UCLA University. So in July 19, I found myself organizing myself to this conference, to get tickets, everything, ta, 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 ta. I was very excited from this travel to United States. And some occasion bring me to rethink about all my work in kindergarten and this vision of Hilbert. And with the guide of my friend, a friend of mine, Amos, I wrote this paper. I wrote the paper, Organic Mathematics. It's a title for a new mathematics. It's a organic mathematics, which is connected to the one of the unsolved problem of Hilbert, the sixth problem of Hilbert about establishing the connection between mathematics and physics. This problem is still considered to be unsolved. So my declaration was that it's possible to solve this problem, but for the solution of this problem, we have to invent new mathematics. So I traveled to the United States with a copy of this paper that I share with you. I make 100 copy of this paper, 100 copy, because it was 100 to Hilbert conference. And yes. I found 100 mathematicians to share this paper with them. No one invited me to give a lecture there, but I was very excited and I gave it to the leading mathematician. As a mathematician, with the excitement of discovering new mathematics as a solution to the sixth problem for Hilbert. So since then, I'm crazy. Since then, I'm working for this exciting project. Yes, so I'm very. So this was the beginning. Yes, the beginning was in this excited event. Yes.
Wow, that is so fantastic. And it is truly inspiring. Why? Because when something like in the conference, when something you were presenting, immediately it clicked and then it connected, opened a lot of doors. And that's how we started talking. And that's how, we have this interview today to spread the knowledge. So, of course, we can have keep going on in series. And I would like you to come again and again, because this is super exciting. And but now I want to actually get into a very interesting part. And as you mentioned, and I saw in your website, a very fantastic interactive session with the kindergarten children, and the excitement and the way the kids were exploring and being curious about going along, solving problems, and, finding out their own ways to do it, coming upon to inferences, just like a scientist too. Just like a researcher goes from one step to the next. So how was the journey? How did it start? Why did you choose kindergarten? Which is, of course, very interesting to me because I work with children. And I find that the children are much more mature and much more not mature in the works, but not mature in understanding the ways of the universe, the kind of concepts that the children have. But I would like to know that how did this journey, like you said, you went to the kindergarten, how did it impact your research further, and what is the journey like? Why did you choose that age group to start with?
Yes, I started to work in kindergarten. It was in 1988 under the supervision of Professor Gidon Karmi. He was a physicist, and he made a PhD under the great physicist, very known physicist named David Bohm. David Bohm is a well-known physicist. He was a friend of Krishnamurti, if you know Krishnamurti from India. They were a very good friend. And Gidon Karmi made a PhD under his supervision. He was a physicist, but in the age of 60, he realized, Gidon Karmi, that the great potential is in kindergarten, in the mind of young children. So I was, as assistant, I started to work under his guidance, but after 2 years we separate, and I start to lead my own project. So at the beginning, we teach science in kindergarten, I concept it was, and I was very, very impressed and very excited for working in kindergarten from the children and with the kindergarten. So I started excited journey in the environment of young generation, which it's continued until today. Until today, I'm working in project concerning. So what I want to say that the first application, if we're talking about application of a theory, is to go to the origin, to go to kindergarten. And what I get from working with children is that they are very curiosity, they love mathematics, they are open-minded. And if we'll talk later about the great Indian mathematician Ramanujan, my great inspiration, I can say that in kindergarten, the children love mathematics. It changed when they go to school. We can go later, but
Yeah.
so I believe we can generate many Ramanujan, many, not as such as Ramanujan, but we can lead a project start it in your country, in India, generating many, many Ramanujan.
Many, many geniuses. Yes.
Because they love mathematics, and we have to know how to touch their eye intelligence. They have eye intelligence before the training school, before the traditional system make mathematics as boring. Understand?
True, true. And I agree evermore.
So my discovery, my first discovery is that the great potential of working in kindergarten, but not to teach them what the adults know, but to go to listen to them, to learn with them, to discover with them things. Okay, we develop the pedagogy of the unknown. The teacher, kindergarten, don't go to school to teach what they know. They're going to interact with things that don't know.
Correct.
You see?
Yes.
A book that, yes.
Wonderful.
So,
and in fact, if I may just ask about your thought, because when I saw the video, I saw that you shared a story where the teacher and the student, there was a unparalleled dynamics to it, because the student said something and the teacher realized that I'm wrong, and a fantastic thing happened. One of the children came up and said, oh, then he becomes the teacher. And that is so impactful. Of course, that I see it in a different way, but what is your thought about that? That is so interesting.
You got the main point. It's very good. In this video, you can share the audience also the link to this video if they want to work together tomorrow with the children. This is a very nice and important story in the history of mathematics, when the great mathematician, philosopher Pythagoras, everyone know about Pythagoras, the theorem of Pythagoras in a straight triangle.
Yes.
Pythagoras discovered that the earth is round. And he discovered the connection between mathematics and music. Yes? He had a school. It was very difficult to go to enter the school. Very hard examination. For example, you have to be in silence for 1 or 2 years to get into the school. And one of his students, Hippasus, discovered a problem in his theory. There's approach that everything is number, that you can describe anything by number. And Hippasus discovered that there are existence of non-rational number, irrational number, which contradict Pythagoras' theory. So the discussion with the children, how should Pythagoras treat his this young student who discovered that is a mistake. So the young children, Itamar, from the kindergarten, when he was 5 or 6 years old, said, did the Pythagoras made him a teacher? But unfortunately, if you read the real story, you'll see that it was very tragedy. They didn't respond Hippasus well. They threw him, and there's the legend even that he was punished and was drawing in the sea.
Yeah. Yes.
So
Yes.
I think that this story is very important in the context of the project, that mathematics was developed in a non-dialogic approach. There's a teacher
Mm.
and a student. It's authority. The student
Yeah.
have to know exactly what the teacher knows. And this is from generation to the generation, the development of mathematics.
Yeah.
What
Top down.
we suggest for a change is a different approach. It is the dialogic approach to mathematics. When the teacher and the student is the eye level, okay, there's a dialogue. And
Yes.
this generates the change. We want to develop a new project in mathematics with a dialogic approach. And this is why the story of Pythagoras and Hippasus is important.
Right.
Okay, so you got the point, yes.
Absolutely. That is fantastic. In fact, that's very important. So now let's quickly jump into soft logic. Now, what does it mean? Tell us more about it. Like a person like me who is non-mathematical in training, how do you explain the soft logic and the scope of zero?
I have a wonderful experience in India, this visit in India, and I hope to visit India again soon. So it's easy to explain soft logic in the term of the wonderful Indian culture. The warm people, the intelligent, the yes and no combined, as I said, together, yes and no. Okay?
No, it's only
Flexibility.
the nod, up and down.
So
Yes.
the Indian invented zero. It was in the 700 before after counting. The Indian invents the zero, which is an amazing discovery for mathematics, enable us to write number. And soft logic is connected to zero.
Ramanujan's work, like you mentioned.
Ramanujan, the greatest Indian mathematician who invented when he was in school, he corrected his teacher. His teacher said that every number divided by itself is one, but Ramanujan said no. Zero divided by zero can be any number, because any number you multiply by zero can be zero. So Ramanujan said zero divided by zero is any number. So this can be explained as the origin of soft logic. In soft logic, we say zero is not nothing. It's not nothing. If you want nothing, share an empty page. If you write zero, then it's not nothing. Zero is infinite wall. It's an infinite wall of small size. So we make a distinction between the different multiplication of zero. 2 multiply 0 is not 3 multiply 0. So we invent the zero axis, the zero line. It's a new coordinate system. We invent new kind of number, which are called soft number, similar to complex number, who know. And from this, we develop a mathematics essence of logic that I present in the conference. And anyone who wants to know can search for in the internet. There are several of published papers on this topic. Soft logic, right in the Google, soft logic.
Yes, but I will, of course, share all your connects, your email, your website, social media, all of that. I'm going to put it down in along with this interview recording, the video. But the next thing comes is, what is the scope of implementation? How do we implement it?
First of all, implementation is very important. Although I'm a theoretical mathematician, I'm looking forward for the implementation. So first of all, we have a mathematical theory, a pure mathematical theory, which is nice. We can write papers, investigation. I have already established connection with Indian mathematicians who are interested and want collaboration and develop it in India, which I'm looking forward to that.
Wonderful.
Specific name. Education. To start in kindergarten, to work in a dialogue approach, to teach the kindergarten what is a partition of a number, which was the investigation of Ramanujan. When you ask a question and you have many answer. What are the partition of 3? 1 plus 1 plus 1, or 2 plus 1, or 3. The partition of 4, there are 5 partitions. So you start with this, and you stimulate and train the brain to be more flexible. So the first implementation, education, we can start it today. We already have a good meeting in KISS school, and we are discussing possibility of collaboration. Yes? So education is the first thing. Second, well-being. The conference was about well-being, positive psychology, well-being. I believe that high level of mathematics develop the well-being, develop the psychology. So it's a very powerful implementation. If we can help to people who might suffer from illness, from mental illness, okay? Some disease, some mental illness. If we can support them with this new language, they can be more happy, less depression. Do you understand?
Yes,
this is
yes.
very practical.
That is where maths will meet philosophy, consciousness, well-being, education, learning. That's a lot of realms.
Besides mental pills, we can train with treatment of mathematics, soft mathematics, to help people today to be more happy, less depression. Okay?
Yeah.
It's
true.
Simplification.
That's something very important. One of the work that I do.
Medicine, to understand the brain. You need to understand the brain, you need new mathematics.
New mathematics,
so
mapping it. Yes.
Think about all the equipment that you put on the brain, and you measure them with our tools. So it can improve medicine.
Yes.
AI, artificial intelligence, ChatGPT.
Yes.
Okay. All these.
All is AI now, algorithms and artificial intelligence.
So I'm telling you that it's a very exciting project, and we are looking forward for people, serious people from India, researcher, mathematician, psychologists, medicine, doctors, AI. Let's do it. Let's also meet the spiritual. Yes. I heard the presentation of Gurdjieff Shiri, the enlightenment person. It was very exciting to see all these people. I wanted to talk, to hug him and tell him about the soft logic discovery. So he will be very happy. He said that he's excited always. So he will be very happy to know that there's a new zero.
Yes, yes, absolutely. The soft zero. So before we close, Dr. Moshe, what is your message that you want to give to the youth, the intellectual, the scientist, the researcher, the philosopher, the techie, all these people who are listening, the audience? What is that message that you want to give quickly?
I want to say that we are living in a very challenged period for the history of human being. The coronavirus, the dangers of the acclim, dangers, and also what is happening today in Israel in the politics is all very challenging. Okay.
Yes.
But these dangers have also optimism, is the possibility for a change, and the center of the change is the awareness, is the consciousness, is the culture of India, the Enlightenment people, Buddha, etc. All this wonderful. But my message is that there should be a combination between the East knowledge and the West knowledge, to combine it. And if we'll be able to combine it, and I think that with mathematics in the center, that can make the bridge, and this is will be our contribution, new mathematics, new zero to the Indian people, and together India and Israel can change the world. Yes. And we will start it this moment now. When we finish the interview, we'll start to work.
Absolutely. And that's a wonderful message, Dr. Moshe. And I believe that this is the bridge that will connect different realms, different aspects of our life, and make us live in a world which is definitely better, but not only better, but happier. So, with that, stay tuned for the next episode to learn more about the new projects and collaborations. Signing off, Mona Lisa. Thank you so much.
Okay, thank you very much. It was my great pleasure.